like building Lego pieces. I am very obsessed, especially with these tiny, tiny Lego ones. And so it's hard to think of this piece as a bunch of tiny, tiny Legos, but the smallest pieces that make up this little Lego cat are this big. That's the smallest piece, and that is how these are built on a lot of these tiny, tiny blocks. So, what about you? And what about the table that you might be sitting at, or the chair you might be sitting on, or the plants outside, the car you drive, your parents drive, your water bottles? What are all of these things made out of? That's today's lesson. Let's go. Everything in this universe that exists, that has mass and takes up space, is called matter. And how we break down matter is into smaller and smaller and smaller parts, right? So for example, a chair. You can break it down into the back of the chair, the seating of the chair, the legs of the chair. Those are the parts of the chair, right? And then what it is made out of might be wood and plastic and some other things. And then what is wood made out of? You start getting smaller and smaller and smaller. And that's when we reach the smallest unit of matter, which is atoms. So elements are all the different natural things that are around us that exist in nature. And we'll talk more about elements later on. But first up, the smallest unit, atoms. Atoms are the tiniest particles of matter. Particle means small, tiny part, right? That is what an atom looks like on the picture there. Well, not really. We'll get into it later. Atoms are made of even smaller particles called subatomic particles. And these subatomic particles are the parts that make up the atom. There's three. We've got protons, electrons, and neutrons. And so let's discuss on each of those. The protons are the ones that I pointed out here, the ones with the plus signs on it. They are positively charged particles, and they are found inside of the nucleus of the atom, which is the center portion. And they have a mass of 1 AMU. AMU means atomic mass unit. So it has 1 mass. The proton is also going to tell you what element that atom is. So there's many, many different elements you may have heard of before, like gold is an element. Hydrogen is an element. Oxygen is an element. Carbon is an element. All of these words that you know and have heard before are elements. So the number of protons a certain atom has is going to help you identify what that atom is of. Is it an atom of gold? Is it an atom of oxygen? The number of protons of the atom is going to let you know what element that atom belongs to. So for example, hydrogen has 1 proton and helium has 2 protons. And then we keep going into lithium, beryllium, boron, carbon, nitrogen, oxygen, and so on. So I'm not gonna sing the entire periodic table. If you want to watch that, I'll link the ASAP science video on that soon. So this is our first introduction into chemistry. Chemistry is looking at the breakdown of how things are formed, right? And how we can make things from very tiny things. So things like making this Lego cat out of tiny pieces of Lego. But we're looking at more of the structure of how things are made at the atomic level right now. So the next particle we'll talk about is the electron. Those are the ones with the minus signs on, because those are negatively charged particles. And they are found on what we call the electron shells, or the energy levels. So those rings that you see the negative particles roaming around, those are called electron shells, or energy levels, or orbits, or rings. There's many different words used to describe the same thing. It's just the energy level at which that electron is. Now, electrons are a funny thing. Right there in that picture, that's why I said it's not exactly what an atom looks like. It's a very simple representation, but you have to remember the mass of an electron is 1/1850th of a proton. So if you were to do a size comparison, if you look at this picture over here, the proton would be the size of this like bowling ball, and the electron's like this marble in comparison, one to the other. So electrons are very tiny, and they necessarily don't add a lot of mass to the atom. So we consider them, for 8th grade purposes, to have a mass of 0 atomic mass units. It's not exactly 0, but it's very close to 0 for our needs, right? If you want to become a chemist and you get more into that, you will be talking about mass of the electron. Right now, don't need to worry about it. Consider it 0. Think of it like this. If you are carrying a very heavy backpack and your friend adds a sticky note to your backpack, are you going to notice that? No, because the mass of the sticky note is nowhere even close to the mass of the backpack that you're already carrying. So that's like the electrons. They're there. We know they're there. But their mass is not adding to the total mass of the atom. Neutrons. These are our neutral particles, which means they don't have a charge, or they have a neutral charge. Same thing. Neutral charge or no charge. That's how we define a neutron. They are also in the nucleus of the atom along with the protons, and they also have an atomic mass unit of 1. So the neutrons and the protons are going to have the same mass, and the electrons are going to be the very tiny ones. And our neutrons are kind of there in the middle as a buffer. If you've ever talked about things like magnetism in school, right? You will remember things like the different sides of a magnet, right? The plus and the plus don't want to bind together, but the plus and the negative do. Opposites attract, likes repel. So in order for all those protons in the center to not repel each other, you need a buffer in between. That's your neutrons. And different atoms will have different amounts of neutrons. So they're not usually going to be the same amount. And we'll talk about how to calculate how many neutrons there are in an atom later on. Don't worry about that for now. Just remember what it is. And that the only element that does not have a neutron is hydrogen. It only has 1 proton, so it doesn't need a buffer with anything else. So it's fine with just its proton and no neutrons. All the other elements are going to have a neutron at least. Atoms, as I said, don't look exactly like that picture. And I'll show you a more accurate picture tomorrow when we go more in depth into this information in class. But if you can already tell just with this picture, the amount of yellow space is most of the atom. So all of that yellow space is empty space. So atoms are mostly made of empty space. So you are mostly made of empty space. The table that I am resting my computer on is made up of mostly empty space. Every atom in this universe is made up of mostly empty space. Now, why doesn't it fall apart? Well, there's a lot of more physics that goes into that. But as of right now, just remember the mass, the actual heaviness of the atom comes from the protons and the neutrons. So remember how we were talking about mass with density before? So now we're talking about mass, but at a very tiny scale. And so in this scale, we measure the mass of the atoms by just adding protons and neutrons. That's that nucleus area in the center. That's where we have our mass. The rest of the atom is mostly empty space in those tiny electrons that are not going to add anything. So all the mass is concentrated in that very center of the atom. And then outside of that nucleus, we have what is called the electron cloud. And in the electron clouds where you find all the electron shells with the electrons in them. So you have your nucleus and your electron cloud. In the nucleus, you have your protons and your neutrons, and in the electron cloud, you have your electrons. That's why it's called an electron cloud. And that is it for today. If you have any questions, let me know in tomorrow's class. And please go ahead and answer the questions down below. There's just like 2-3 questions. It'll be simple, and I'll see you tomorrow.